Welcome to the CESBAMED Training Module 1, titled The CESBAMED Generic Framework Concept and the Multi-Criteria Assessment Methodology. Let us start this training module by asking ourselves a fundamental question. Why do we talk about sustainability? European cities account for around 70% of worldwide energy consumption and 60 to 70% of total carbon dioxide emissions. The population in Europe is the highest when compared to that in other continents. This has a great impact on the rise in temperature, CO2 concentration, and sea level worldwide, together with a reduction in resources, fuel, and energy. In particular, if one had to look at the figures related to the emissions and energy resources utilization by the building and construction sector as published by the EC Commission, one can easily notice a high impact due to this sector. But what can be done to reduce these impacts? We definitely need to increase sustainability of buildings and urban areas, improve the existing built areas while adequately addressing the new projects. According to the UN Agenda 2030 for Sustainable Development, published back in 2015, 17 macro targets of sustainable development and 169 specific targets were defined. These are summarized in this slide by means of pictograms and include sustainable cities and communities, responsible consumption and production, and climate action. Enhancing sustainability is a challenge that requires synergic actions, strategies, projects, and policies. The three major themes with a long-term perspective are the urban system, environment, society, and economy. Many options on which one may operate include quality and accessibility, technologies and performances, materials, and processes, amongst others. The major stakeholders in urban area sustainability are research and academia, industry, public administration, and marketing specialists. This is clearly depicted in the pictogram shown in the slide. Energy-efficient measures and their implementation at district level allow to reach significant and cost-effective improvements compared to a building scale approach. An urban scale approach is frequently the most efficient one due to synergies among buildings, wasted energy exploitation, efficient use of renewable energy sources, cogeneration systems, and economy scale factor. Thinking building by building is definitely not an efficient approach. The main features of decisions made at urban scale include high complexity, large number of stakeholders involved, complex value chain, and many variables to take into account. This makes decision at urban scale quite a challenging task. But what is CESBAMED? CESBAMED is a sustainable cities project which has the following scopes. Particularly the development and testing of a transnational system to assess urban sustainability, the transferring of the assessment system to a training system, and finally the capitalization of the assessment system by promoting the adoption by public administrations. In particular, it has three main objectives: to harmonize assessment systems in Europe, foster the adoption of assessment tools by public administrations, and enhance the sustainability of built environment. The generic framework is perfectly in line with the 9 CESBA principles, which can be summarized as follows: users, sustainability, contextualization, comparability, mass approach, ease of use, open source, collaboration, and finally transparency.
The CESBAMED generic framework is a transnational generic multi-criteria assessment tool which is used to rate the level of sustainability of buildings and urban areas, and also to create urban and buildings assessment tools. Given that it is a generic one, the system must be first contextualized in order to be properly used. Tools deriving from the same source are then harmonized and produce comparable results.
The performance assessment is divided into three main parts. The objective, which rates an urban area on the basis of its performance. Procedural, which goes into the performance analysis with regards to a group of criteria and indicators. And finally, the results, which gives a score and a rating. The SESBAMED assessment tool for urban areas is applicable to both existing and new areas, including all the stages of the life cycle, and supports the planning activities from definition of targets to the result verification. The following are the innovative features brought in by SESBAMED. Mainly, we can notice the following features: rating and assessment tools at urban scale level for existing neighborhoods, rating and assessment tools which are fully contextualized, integration of the building scale and urban scale assessments in a unique decision-making process, the possibility to consider the building in the context of its surrounding area, assessment systems designed to fit public administration needs, comparability, mass approach, ease of use, transparency and collaboration. And finally, one needs to note that this is not for marketing purposes. But why do we need assessment tools? Assessment tools provide objective and reliable information to support decision-making processes. They give the possibility to set reliable, measurable, and verifiable performance targets for urban areas and buildings based on quantitative indicators. They provide a reference common framework for the stakeholders and an easy comparison among urban areas and countries. Assessment tools give us an easy communication among stakeholders while providing a development of common vocabulary for environmental assessment. SESBAMED is a single transnational generic framework with 8 contextualized local tools. Assessment tools are created to fix targets which are objective, credible, measurable, and verifiable. And these tools are also there to address the actions. These assessment tools are relevant and important for policy making, regulations, generation of incentives, green public procurement, urban plans, and action plans. This work is based on existing knowledge and provides tests of existing sets of indicators from other EU projects, urban scale assessment tools, and EU framework of common indicators. The following are the 12 partners contributing to this project, which originate from 7 different countries. This project kicked off back in November of 2016 and will be concluded in October 2019. It has a project value of around 3.2 million euros. The slide shows 7 other EU projects which focus on the building scale, whereas here one may see readily available building scale assessment tools. The EC COM 445, published back in 2014, is an EU common framework in research efficiency opportunities in the building sector. Its aim is to study and identify an EU common framework of indicators and assess the environmental performance of buildings. The slide presents 4 EU projects which are on an urban scale, and these were funded through different funding mechanisms, as one can notice here. 2 assessment tools for the urban scale originated from the previous 4 EU projects.
SESBAMED considers two main reference scales. The first one is the neighborhood scale, which is a traditional one and that is culturally recognized and often not defined officially. City inhabitants recognize its defining traits such as social, cultural, and architectural features. A neighborhood is generally defined by a 200 to 400 square area that can be crossed in around 10 to 15 minutes on foot. Such a scale is appropriate for assessing and studying smaller scale networks, such as areas adequate for walking and cycling, impact of buildings' morphology on the surroundings, local microclimate, daily services, social mixture, segregation, equity, well-being, and culture, amongst other things. The second reference scale is referred to as the block scale. It is easy to identify and it is defined by street intersections. It is generally the oldest urban scale and is also called a cluster. It can coincide with the building scale, especially in the recent developments. A traditional composition would consist of around 5 to 15 buildings, either adjacent or separated, and would often have an internal courtyard. Such a scale is appropriate for detailed analysis of morphology, including density, volume, distribution, and compactness, energy characterization, precise microclimate studies, and in homogeneous neighborhoods, it can be used to study representative blocks as benchmarks for quick prototyping and simulation. The assessment method adopted in the SESBAMED generic framework multi-criteria system is the Sustainable Built Environment method. It is a generic multi-criteria analysis methodology for assessing the sustainability of the built environment. The method is organized into three parts, mainly the issues, categories, and criteria. The sustainability score of assessment is computed through a mathematical procedure which is articulated in three main steps, being the characterization, normalization, and aggregation. As indicated in the previous slides, the performance score is computed through an assessment procedure articulated in three main steps, which are mainly the characterization, normalization, and aggregation. So as you can see in this flowchart, we first start with the characterization step, in which experimental data and design data are inputted in the system, and the system gives us back the indicator's value as output. Following this, these indicator values are normalized, aggregated, and finally one gets a concise score. In the following slides, we'll go in more detail on the presented flowchart. In the characterization step, the indicators, which are mainly either numerical values or reference scenarios, generate numerical values which represent the urban area performances. Such values are determined starting from calculations, experimental measures, and through comparison with reference scenarios, in the case, of course, of qualitative criteria. In the normalization step, different typology of criteria are used for different units of measure. Here, one would redimensionalize and rescale the scores to get normalized scores which are in a range between -1 and +5. The methodology uses a linear normalization function for quantitative criteria. In the normalization step, it's possible to have three kinds of criteria. An HIB, higher is better, would be a criteria in which the higher the indicator value, the better the performance level. The LIB, lower is better, criteria would be in which the lower the indicator value, the better the performance level. A qualitative criteria would mean that only discrete values, each of them is equivalent of a reference scenario defined by the corresponding indicator. In the aggregation step, the normally scores associated with each criterion are given a weight and summed to give a final performance score. There can be different aggregations as follows. Aggregation through criteria, where all normalized scores of criteria in the same category are aggregated. Aggregation through categories, where all normalized scores of categories in the same issue are aggregated. Aggregation through issue, where all normalized scores of issues are aggregated. The SESBAMED generic framework at urban scale level mainly targets 7 issues, which can be divided in 23 categories, which hold a total of 178 criteria and indicators. Let us see in more detail what we understand by issue, category, and criterion. The issue is the macro theme chosen and recognized as relevant for assessing the sustainability of a building or urban area. The category is a particular aspect pertaining to a specific issue, and the criterion is a specific aspect of a relative category. They represent the basic assessment entries used to characterize each building or urban area since the very beginning of the assessment process. Each criteria is associated to an indicator, where an indicator is a methodology which allows to characterize the building performance. The following is a hierarchy of the framework, in which each issue is divided into a number of categories and each category is divided into a number of criteria and indicators. The 7 issues which are targeted are the built urban system, the economy, energy, atmospheric emissions, non-renewable resources, environment, and finally social aspects. The 23 categories are listed in their respective 7 issues as follows. Under Built Urban System, one can find urban structure and form together with transportation and infrastructure. Under Economy, one can find economic structure and value, economic activity together with cost and investment. Under Energy, there is non-renewable energy, renewable and decarbonized energy, and finally energy recycling and storage. Atmospheric emissions are under the same title of atmospheric emissions. Issue E, which is non-renewable resources, is divided into 3 categories, which are potable water, storm water and grey water, solid and liquid wastes, and finally resource consumption, retention and maintenance. For issue F, which is environment, one can find another further 3 categories, which are environmental impacts, outdoor environmental quality, ecosystems and landscapes. The last issue, which is social aspects, is divided into 8 categories, which are listed as follows: safety and accessibility, traffic and mobility services, communication services, public and private facilities and services, local food, management and community involvement, society, culture and heritage, and the last one, perceptual. The following is an example of how the issues, categories and criteria are related to each other in this particular framework. In this case, we are considering the built urban systems issue, which is then divided into 2 categories, being the urban structure and form and transportation and infrastructure, and for each category we will find a number of criteria. So in this case, for example, for urban structure and form, we will find 7 criteria, whereas for the transportation infrastructure category, we will find 10 criteria. Let us now define a number of terms which will be used in this series of training modules. A criterion is an assessment item which permits to analyze a specific performance. All criteria are by default performances. In order to make a certain criterion operative, it is necessary to combine it with a physical quantity or scenario, generally known as the indicator. The indicator, in fact, is the physical quantity or qualitative scenario that allows to quantify the performance with respect to an assessment criterion. Quantitative indicators have a unit of measure. Examples of criteria indicators and their relative units of measure are shown in this table. For example, if we consider criterion A2.6, which is related to the connectivity of the street networks, we'll see that the indicator is the number of intersections present in the analyzed area related to the overall surface area, and the unit of measure would be the number of intersections per kilometer squared. This chart presents the distribution of the criteria across the 7 issues. So, for example, for energy, we find 39 criteria, whereas for social aspects, we'll find 37 criteria. The CESBA Sustainable Neighbourhoods tool is based on the 2030 EU Agenda Policies and Targets and is required to compare the performances at a transnational level. In addition, the assessment tools must reflect the local priorities and the local context. The CESBA Sustainable Neighbourhoods tool works on providing a generic EU framework with the proper contextualization in order to generate assessment tools for any city, where the generated tools coming from this generic framework are harmonized and comparable. This can be better visualized and understood in this slide. So by starting with the generic framework, by adding the proper contextualization, one can apply or generate different tools for different cities. We are here presenting a number of them like Torino, Barcelona, Lyon, and so on and so forth. Using this generic framework, 9 assessment tools were in fact developed and are in test phase in the following cities of Turin, Barcelona, Marseille, Lyon, Athens, Zagreb, Sant Cugat de Val, Udine, and Malta. In generating the tool for a particular city, one needs to consider the city morphology, which, as defined by the generic framework, has to be defined in terms of 6 levels. So we start with level 1, which involves people and activities. Then in level 2, we see connections and street network. Level 3, we see the urban blocks. Level 4, we study the site topography. Level 5, the land use. And finally, in level 6, one would see the weather conditions. So in the regional tool creation, an assessment methodology and criteria were adopted to generate a generic framework, which we refer to it as the CESBA MED generic framework. This generic framework has 3 main parts, which are the criteria selection, the performance scales definition, and the weights assignment, which together with the local context would be able to form a regional or city tool. Let us now go in further detail. To contextualize the generic framework and produce an SN local tool, the following 3 steps are necessary. First, we need to select the active criteria from the whole list of the CESBA generic framework. Only the KPIs, which are the key performance indicators, are mandatory for all local SN tools. There isn't a minimum number of criteria to be selected. Then, one needs to define the benchmark for criteria, which consists in the definition of the scoring scale for each criteria selected, as we said before, from a value of -1 to +5. And finally, give a weight assignment to the criteria, categories and issues in a percentage. The final total score denotes the global performance of the urban area or the building. In the first phase of the contextualization, we perform the criteria selection, in which a number of issues, categories, and criteria are selected to be used from the generic framework. The generic framework and system are modular and thus permit this to be done in an easy way. The average number of criteria which is recommended to be chosen is around 40 to 50 criteria. In the second phase of the contextualization, we perform the scale definition. Particularly, the score can go from -1 to 5, and 1 is guided by either laws and regulations, technical legislation, literature, statistical data, and simulation data in order to associate a particular score to the indicator value. This can be better visualized in this particular example, particularly criteria A2.6, which is related to the connectivity of the street network, in which we see an example being applied for a particular normalized score. The final step of the contextualization is the weight assignment to the criteria, and here we are seeing a particular weight for one of the criteria, which is the conservation of land, particularly criteria A1.7. As we have seen in previous slides, the weight assignments is made both at the criteria level, categories level, and issues level to finally generate a final score. This can be better seen in this slide, in which the radar plot also gives us an indication of the balance between the different issues and categories. The tool is also able to give us an indication of the current state and how it relates or how it compares to the targeted performances. So, to summarize, the CESBAMED software is based on 2 parts. So first we start from the generic framework, and finally we can develop our own regional tool through the selection and contextualization process. Although the generic framework presents us with a number of criteria, not all of them can be defined as key performance indicators. In fact, the majority of them would be optional criteria which can be inserted or not depending on the choice of the designer. The most important thing to notice is the inclusion of the key performance indicators, better known as KPIs. And these would be coming from all the 7 issues which are listed here in this diagram. So, as a general guidelines, one would recommend that to include the KPIs and in addition to that, a number of optional criteria from across all the spectrum, including the building, urban system, economy, energy, atmospheric emissions, non-renewable resources, environment, and social aspect, to have a more holistic view. Let us now go in the selection of the KPIs. Particularly, different cities from the different countries participating in the CESBA MED project selected and contributed to the selection of KPIs in order to have a holistic and more representative list of KPIs. These KPIs are based on common computational methodologies in order to obtain comparable results and are related to the following, such as soil, water, emissions, waste, energy, pollution, mobility, services, energy cost, and participation. So let us now go through the different issues and categories and see the related KPIs. So for example, under Built Urban System we'll find one KPI, which is the conservation of land, and under Economy we find KPI B3.3, which is related to the use stage energy cost for public buildings. Under Energy we find 5 KPIs, which are mainly related to both thermal energy consumption for buildings, electrical energy consumption for building operations, and so on and so forth. The KPIs for the atmospheric emissions are the total GHG emissions from primary energy used in building operations, whereas for renewable sources we find 2 KPIs, one related to the consumption of water for residential population, and the second would be the consumption of water for non-residential building systems. In terms of environment, we have 2 KPIs, which are the recharge of groundwater through permeable paving or landscaping, and the ambient air quality with respect to particulates which are less than 10 μ over a 1-year period. In terms of social aspects, we find 4 defined KPIs, which are the performance of the public transport, quality of pedestrian and bicycle network, availability and proximity of key services, and community involvement in urban planning activities. The KPI distribution with respect to the issues is represented on this slide. So, as an outcome or product of this tool, a CESBA MED passport is generated for both buildings and neighborhoods, and which has the aim to transnationally compare the assessment results, make easier sharing best practices, and facilitates the measurement of the contribution to a common objective. As a generic aim, the passport helps in harmonization of the common metrics for key issues. So, even though we might have different cities, since they are based on a set of selected KPIs, we would have a means to compare different cities and be able to assess their performance and best practices between each other. So, for example, if we get a score from Torino and we get a score from Barcelona, since they have the same comparable meaning, based on the same KPIs, we can better evaluate and compare the performance of these 2 cities. So, as a summary, the CESBA MED passport is based on a global thought in which the Sustainable Development Goals generate the KPIs based on the assessment of local policies referred to global targets and connect to the local scenario. So we start from a global view and finally act at a regional or city view. The CESBA MED consortium participated in a number of dissemination events, such as the Conference on Sustainable Buildings held on 4 December 2017 in Brussels, Belgium, and a number of interviews, such as that given by Andrea Moro, who is the Vice President of CESBA, on opportunities for levels. In addition, a number of testing of new levels system on public buildings was performed. The SESBAMED consortium participated in the WSBE 2017 Work Conference held in Hong Kong, where a number of important results were presented. These results show that they are in line with the Synergy with Non-European Initiatives report for 2030. Finally, the introduction of SESBA passport to the Unity Cities of the United Nations Environment was made at a meeting held in Paris back in January 2018. While hoping that you found this module interesting, we thank you for your kind attention.